Hello children, welcome to Riot Tuition Classes. We are doing ICSE Standard 10 Physics Numerical Revision Series. I'm on lecture 2. I told you all children, I'm going to make some 10 lectures, okay? You just go through these 10 lectures. I'm sure children, you'll be through you'll become very confident in solving physics numericals of Standard 10, okay? So you can see here, this is question number 1. A charge of 100 coulombs. A charge of 100 coulombs flows through a conductor for 3 minutes and 20 seconds. A charge of 100 coulombs. So what am I going to do, children? My first step in physics numerical is writing everything in notation form. Charges represented by letter Q. Q. Charges always represented by letter Q. So Q is equal to 100 coulombs. Okay? Then children, flows through a conductor for 3 seconds and 20 minutes. This is time. Qt is 3 minutes and 20 seconds. 3 minutes and 20 seconds. 3 minutes, 20 seconds. So keep it in mind, children. Everything should be in SI unit. Minute is not in SI unit. So minute ko convert karunga. 3 into 20, 60. 60 plus 20. कितना हो गया 80 seconds. Totally 80 seconds हो गया. 3 minutes is 60 seconds. Sorry, 3. I'm so sorry, children. 3 minutes is 3 into 60, 180. 180 seconds. 180 plus 20, 200 seconds. This is totally 200 seconds. Okay. Find the magnitude of current flowing through the conductor. They want me to find, okay, current flowing through the conductor. I, question mark. I is question mark. Children, the current is defined as, please have a look here. Current is defined as a rate of flow of electric charge. Rate of flow of electric charge. Okay. मतलब जैसा I is equal to Q upon T. Got it? I is what? Q upon T. Rate of flow of electric charge. I is equal to Q upon T. Got it? So now we can substitute the values, children. Therefore, what will happen, children? I is equal to Q is how much, children? 100 coulombs, okay? Upon T is how much, children? 20, 200 seconds, 200 seconds, okay? So what I get, I is equal to 100 ones are 100 2 times 1 upon 2 is 0.5. This coulomb per second is nothing but ampere, okay? Ampere. So current is, therefore, I is equal to 0.1 0.5 ampere. Magnitude of current, so answer in words, magnitude of current flowing through the conductor, magnitude of the way they have asked, the answer should be in the same wordings. Magnitude of current flowing through the conductor, flowing through conductor is equal to, children, how much conductor is equal to 0.5 ampere. Okay, we go to the next question. Question number 2, children. Two equal and unlike parallel forces of magnitude 16 Newton act on a rigid body, such that moment of couple is 12 Newton meter. Find the arm of the couple. Children, read it properly. Two equal and unlike parallel forces. Two forces of magnitude 16 Newton. So what is the forces? Magnitude is 16 Newton. Okay. Each of these forces are equal forces. मतलब दोनों force का magnitude 16 Newton है. They act on a rigid body. And the moment of couple is 12 Newton meter. And find the arm of the couple. So what is moment of couple? Children, you learned a formula. Moment of couple is equal to moment of couple is equal to magnitude of either force, okay, any one force into arm of the couple. That is distance between the forces. Arm of the couple. Arm of the couple is nothing but distance between the two forces, couple forces. Okay. So remember this, children. What is that? What is the formula, children? Okay. Please try to get this formula. our moment of couple is equal to, actually it is magnitude of either force into arm of the couple. Okay, so now in this sum, when you see children, in this sum, what is given? Two equal and unlike parallel force of magnitude 16 Newton. What is magnitude of each force? Either force equal, either force, okay, is actually equal to how much? 16 Newton, okay? And what else is given? Moment of couple is given. Moment of couple. What is given? Moment of couple is 12 Newton meters. So now you can substitute in the formula. The moment of couple के जगह में 12 Newton force is equal to either force is 16 into, what is this? Arm of the couple. Arm of couple. Arm of the couple. Okay, so how much you get, children? Arm of the couple is nothing but distance between the two forces. So you get 12 upon 16 is equal to arm of the couple. Okay, 4 3 times. 4 times. 6. So arm of the couple equal, arm of the couple equal 0.75 Newton meter, because arm of the couple is nothing but distance between the two forces. Okay, so I hope everybody has got this sum, a very simple sum and very easy sum. Okay, we go to the next sum, children. We go to question number 3. We go to question number, a boy of, question number 3, a boy of mass 30 kg is sitting at a distance of 1 meter from the middle of the seesaw. Where must a boy of mass 40 kg sit to balance a seesaw? A boy of mass 30 kg is sitting at a distance of 1 meter from the middle of seesaw. You know what is a seesaw? Everybody knows it, okay? Where must a boy of mass 40 kg sit to balance a seesaw? So what I do, just to make it look easy, I just take two boys are involved. So एक boy को boy one बोलता हूँ, दूसरा boy को boy two बोलता हूँ. ये boy one का mass कितना है? M1 30 kgs. If boy 2 का mass कितना है बेटा? M2 40 kgs. Got it? They are sitting from the middle of seesaw. Where must a boy, so whereas this boy 1, he is sitting at a distance of 1 meter from the middle of seesaw. That middle of the seesaw is a fulcrum. Middle of the seesaw is a fulcrum. Are you getting me here? So boy 1 is sitting at a distance of 1 meter. Can I take it as D1? Okay. Okay, D1, distance from the fulcrum, 1 meter. And what is, they are asked, where must a boy of mass 40 kg sit to balance the seesaw? So D2 is the distance of this fulcrum, okay, of the boy 2, distance from fulcrum. So naturally here, can I say by the principle of movement? See here, boy 1 is sitting like this. He is going to produce, children, please have a look here. This is anti-clockwise movement. This is anti-clockwise movement. Whereas boy 2 is sitting here, he is going to produce a clockwise movement. When the anti-clockwise movement and clockwise movement are equal, the seesaw will sit in balance. Okay, the seesaw will be balanced. That it will be in equilibrium. It will be in equilibrium. Okay, that means the movement of force due to boy 1 will should be equal to movement of force due to boy 2. Then only this, got it? Both the seesaw will be in equilibrium. It will be in balance. Okay. So we say by the principle of movements, by the principle of movements, anti-clockwise movement or clockwise, anti-clockwise movement or movement of force. I'll just say movement of force due to boy 1 equal movement of force due to boy 2. this is actually anti-clockwise movement. This is clockwise movement. Okay. So anti-clockwise movement equal clockwise movement रहेगा तो equilibrium में रहेगा. Okay. They're saying it should be in balance. Okay. So moment of force का formula क्या है? force into distance. Okay. Force into distance. Okay. So what I do is here the force into distance. So m1 into g. That and here also it will become like m1 into g into d1 distance equal m2 into g into d2. Actually, what happens? Nobody writes a g. They just show m1 into d1 equal m2 into d2. Just for the sake of your understanding. Moment of force is always force into distance. तो इधर काय के लिए m1 लिखता है बार बार, इधर खाली m2 लिखता है. काय के लिए एक्चुअली फोर्स का फॉर्मूला आनी चाहिए. तो फोर्स का क्या फॉर्मूला आएगा बेटा? m1 into g. तो ये g इधर भी आते इधर भी आता तो कैंसिल हो जाता है. इसके लिए इन लोग बाद में दिखाते नहीं है. तो आपको भी नहीं दिखाना है, मैंने खाली समझाने के लिए बताया. इधर जी भी लिख दिया है. तो 30 into 1 meter is equal to children your 40 into d2. Okay. So what will happen? 30 upon 40 is equal to d2. Got it? So this is d2 equals 0.75. Okay, 75 meter. So that boy too should sit at this. Where must a boy of mass 40 kg sit? Boy of mass 40 kg, boy of mass 40 kg should sit at a distance of 0.75 meter. What it is? 0.75 meter. 0.75 meter. You should sit at a distance of, boy of mass 40 kg should sit at a distance of 0.75 meter from the fulcrum. Okay, children. I think this is apparently a simple sum, children. Okay, we go to the next sum. That is question number 4. We go to the question number 4. We go to the question number 4, children. The two forces of 2 Newton each act in opposite direction at the end of the meter scale. You can say at the end of the meter scale, okay? Now what they're saying, children, calculate the resultant moment of force about 50 centimeters. Now, this is fairly a simple question, children. Two forces of 2 Newton each act in opposite direction. So purposely I draw a meter scale, okay? What happens? The two forces I'm drawing, they are acting in opposite direction. The two forces I'm drawing, they are acting in opposite direction. Opposite direction. You can see here, children, if one is acting in a downward direction, the other one is acting in upward direction. They are opposite. Equal there, but they're acting in opposite direction. So naturally, we have learned when two equal forces, okay, act in opposite direction, and you can see the line of action is parallel. They are called as couple forces. So here I can easily find in the resultant movement is nothing but movement of couple. The moment of couple will be, the formula is either force into arm of the couple. Arm of the couple is the distance of both, the distance between the two forces, 50 centimeter and 50 centimeter, 100 centimeter. Got it? So what it will be here? What am I going to do? I'm going to calculate the moment of couple. So I'm going to write here, since the two forces are equal and act in opposite directions, such that since the two forces are equal and act in opposite directions, you can see one is acting in a downward direction, other one is acting in the upward direction. And the line of action, and the force or line of action of force, you can look at it, okay, they are parallel. So they form, these two forces together form a couple force, okay? Forces are equal and opposite in direction, hence they form a couple force. They form a couple force. So the resultant moment of force is nothing but moment of couple. Therefore, moment of couple is equal to, I taught you the formula in the previous, either force, any one of these force, either force into arm of the couple. Arm of couple is nothing but distance between the couple. Distance between the couple. Either force, you can see here, children, they are 2 Newton. Okay. Into arm of the couple. Arm of the couple, distance between the two, 100 centimeter. 100 centimeter, I want it in meter because this is Newton. And 100 centimeter Newton is an SI unit. And 100 centimeter is a CGS unit. So naturally, this is 2 Newton. Okay? 100 divided by 100. It will become 1 meter. Are you getting me here? 100 divided by 100, it will become 1 meter. So what is the answer, children? 2 Newton meter. What is the moment of couple, children? 2 Newton meter. That is nothing but the resultant moment of force. The resultant moment of force is resultant moment of force equal to Newton meter. I hope everybody has got this answer clear. Question number 4, not a difficult one, children. Quite a simple one. We go to the next question. Question number 5. Question number 5, children. A body of mass 0.5 kg falls from a height of 20 meter to a height of 12 meter above the ground level. A body of mass 0.5 kg falls from a height of 20 meter to a height of 12 meter above the ground level. That means, see, the body was at a height of 20 meter above the ground. This is the ground. Are you getting me a ground level? Okay, this is the ground level. Okay, it was at a height of 20 meter above the ground level. Now, when it was here, it had a potential energy. Got it? Now, when it has come to, please have a look here, when it is falling down, it has come to this position, which is 12 meter above the ground level. Still, it has potential energy, but less. Earlier, it had more. Now, it has got less. So, what is that loss? How much it has lost? Are you getting me? We want to find out. Are you getting me in this question? What is the loss of potential energy? So, what I do is, children, so simple. I told you always write in short. M equal, what I can say, children, M equal 0.5 kg. M equal 0.5 kg. M equal 0.5 kg. Okay, children? Then what I do, children? I take this height, okay, above the ground level H1 as 20 meters. 20 meters. And I take H2 above the ground level here, 12 meters. Are you getting me, children? So what is the loss of potential energy? So there is a formula, children. Loss of potential energy is equal to potential energy at a height of 20 meter. Okay, potential energy at a height of 20 meter minus potential energy at a height of 20 meters at a height of 20 meters minus potential energy at a height of at a height of 12 meters. That means this potential energy formula is mg. I'm taking h1 as a height of 20 meter minus mgh2. Correct? Potential energy formula is mgh. Okay, so mgh1 minus mgh2. What is common, children? mg h1 minus h2. Now put all the values, children. 0.5 kg. Okay, into J is 10 meter per second square into bracket H1 minus H2, 20 minus 12. Okay. So how much you get? This 0.5 into 10, 5 decimal goes off into 8. Okay. So it is 40 joules. What it will be? 40 joules. 40 joules. A very simple question, children. Go to question number 6. We go to question number 6. Children, we go to question number मूविंग बॉडी प्रेजेंट टेंस में मतलब बॉडी मूव हो रहा है मूविंग बॉडी वेइंग 400 न्यूटन its weight is what is given, children? Weight is 400 newton. Weight is 400 newton, possesses 500 joules. Matlab it has kinetic energy. What kinetic energy it has, children? 500 joules. How much? 500 joules. Okay. Calculate the velocity with which it is moving. That means in the present tense में उसका जो velocity था, velocity they are asking. Children, many of the children will jump. Kinetic energy is half mv square. Kinetic energy का formula half mv square. Kinetic energy का formula, लेकिन ये m kinetic energy तो मालूम है, m नहीं मालूम, and v I want to find. But m नहीं मालूम रहेगा तो v कैसे निकालूंगा? So M, why they given weight? So weight is equal to, just have a look at the sum, children. So easy. Weight is M into G. Got it? Weight is 400 Newton is equal to, M is how much, children? We don't know, but into G is 10. So 400 upon 10 is equal to M. 0 cut. So M is equal to 40 kgs. Okay. SI unit. Why did I find M? Now I know the formula for kinetic energy. Kinetic energy equal half mv square. So what is kinetic energy? 500 is equal to half into 40 into v square. 220 times, children. So 500 upon 20 is equal to v square. That means v square, 2 ones are 225s are. So v square equal 25. So v equal, therefore v equal 5. Got it? So v equal 5 meter per second. So velocity equal answer. Calculate the velocity which the body was moving. Okay. So velocity equal, how much you get, children? With which body is moving is 5 meter per second. You should always write the answer the way they have asked the question. Okay, children? Now we go to the next question. Question number 7, children. Question number 7. Question number 7. Children, a hot solid of mass 60 gram is placed in 150 gram of water at 20 degrees Celsius, and the final study temperature recorded is 25 degrees Celsius. Calculate the specific heat capacity of the solid. A very simple thing. Only two things are involved, a solid, hot solid, and water. A hot solid and water are involved. So see the way I write, my way of doing, okay, this sums, okay? It's a question of mixtures, okay? It's a question of mixtures, okay? So here, listen, what I do, I write a hot solid, a solution, I write first. Here I'm talking about hot solid. Okay, and here I'm talking about water. Only these two things are involved. Okay. So now you see, hot solid of mass 60 gram. Hot solid of mass 60 gram. Hot solid of mass 60 gram. So mass of hot solid is what, children? M1, 60 gram. Okay. At 100 degrees Celsius. Oh, its initial temperature. Initial temperature is 60 degrees Celsius, 100 degrees Celsius, sorry, is a hot solid of mass 60 gram at 100 degrees Celsius is placed in 150 gram of water at 20 degrees Celsius. The final study temperature recorded. Okay, so it is placed in 150 gram of water. What is mass of water, children? 150 gram. And what is the initial temperature of water? Initial temperature of water is 20 degrees Celsius. Okay. The final study temperature recorded is 25 degrees. Final temperature, दोनों को mix होने का final temperature is 25 degrees Celsius. You can see here, student. Now calculate the specific heat capacity of the solid. Suppose C of S is specific capacity of solid and C of water is, what you can say, if you want the answer in joules, 4.2 joules per gram degree Celsius. So now you can see that, children, what will happen is, now by principle of mixture, by principle of mixtures, heat lost by hot body is equal to heat gained by cold body, children. So what is heat loss by cold body? M1 into specific capacity of the solid into delta T, that is falling temperature, is equal to M2 into specific capacity of water into rise in temperature. So this delta T is falling, rise in temperature. And here M1 is how much? 60 C of S into, what is falling temperature? 100 minus 20. 100 minus 25. 100 minus 25 is equal to 150. Specific capacity of water is 4.2 joules per gram into delta T. What is delta T, children? Here, rise in temperature, 25 minus 20. From 20, it has come to 25. So 60 into CS into 75 is equal to 150 into 42 into 5. So what is CS, children? Equal to 150 into 42 into 5, the whole thing upon 60 into 75. 75 one time, 75 two times. 5 one time, 5 12 times. Then again, 2 one time, 2 6 times. 6 one time, 6 7 times. So CS is equal to 0.7. Okay, this is 4.2. Okay. So it will become CS equal to 0.7 joules per gram degree Celsius. The specific heat capacity of solid, heat capacity of solid is equal to 0.7 joules per gram degree Celsius. Okay, children, we go to the next one now.